Hi everyone, in this video we'll take a look on how to create another simulation using the SMS software. And let's try to open one of Jasper created simulation models. So I will open our ideal.sms file. I have previously saved on my computer, so let's open this one and let's take a look at what do we have here. Alright, so here we have the model that contains only the bathymetry points, so actually those entire points of the polygon we used previously, and in this case these points basically specify the depth of the water volume we have. What do we have else here? So we don't have the border, as you can see. Well, we can set up some border if we like, or we can just work even without this, especially using our new, or let's say another module which we'll take a look at. So we have two lines here. As you can see, those lines contain vertex points. So exactly by basing on those vertex points, we'll have a split of the area into the grid. Alright, so let's activate module we will be working with. So we'll be working with SMS-FLOW module, and this module allows to specify which part or let's say which side of the line of this black line will be referring to a water touching part or a land touching part. So in other words, if we will activate select feature arc and we would select whatever arc, we would have this blue and brown arrow. So blue arrow means that side which is located at this position will be touching the water, and the side of the arc which has the brown arrow will touch the land. So why is it needed? Such model is needed for analyzing water modules which doesn't have some really strict or certain border. In this case, we just specify the entire parts of bridges, some land areas and other areas which are not touchable by the water. And nextly, on the next step, when we have the bathymetry and we have these arcs that basically limits the water volume, and by the way, this limitation will go through all vertical range. So basically, we can imagine that right now we take a look from the top and we have literally a wall right here. A wall with unlimited hash, so in other words, the water will never touch the area which is shown here. The other thing is that here we don't have any arcs, so looks like water can just flow in it, but we will make the border of the area we are analyzing, and afterwards we will specify what effect do we have on those borders which we'll place around this model. Okay, so to place the model in this to place the border in this model, we have to select create 2D grid frame. Okay, and we have to place just 3 points. So we click once somewhere here, then we can see that when we move the mouse, we have the line drawn all the time. So we have to click somewhere here, and then we can place another point, which will be the orthogonal point, or which will lie on a orthogonal line to this line we created previously by using the first 2 clicks. So let's click one more, time, and we have the imaginary border, which will be used for data analysis. So and this analysis involves how water moves between these volumes which are connected by this bottleneck, and other parameters, but mostly it's about water level and directions of waves. So we can even take a look on how waves are being changed through the simulation. That's why this module allows us even to create wind simulation. Okay, but let's make a step by step in our simulation. So we have initial model. We have imaginary border, which will border our analyzed area, and we would like to make a conversion to something we can analyze. And something we can analyze is always grid. In that meaning, we took a look on previous video, or it's the Cartesian grid. In this case, we'll be working on Cartesian grid because this model, once again, so CMS-FLOW model allows us to work with Cartesian grid only. In conversional menu, it's just called as 2D grid, but it's the Cartesian grid. So let's click it. And what do we have? So we have the actual information about our imaginary border we created previously. We have a configuration of what will be separation of this rectangle area, and we can specify separation using cell length and width, so horizontal size and the vertical size, so I and J. So one is horizontal direction, another is the vertical direction. Or we can just specify a number of cells in each of the directions. Alright, in my case, I will say that horizontally I will have 60 cells, and vertically, let's say I will have 75. Well, in this case, why do I choose 60 and 75? I just take a look on approximate ratio between horizontal size of this area and the vertical one. So I just approximately choose this 60 on 75. And what do we have to choose else? So moreover, we have to choose the bathymetry dataset. So we can use some constant values. So this dip, which we'll specify here, will be same for this whole area which will be involved in analysis. But in our case, since we have the scatter data, so it means we have the bathymetry points. So let's choose it. So let's choose scatter set in this drop down box, and let's select the exact scatter set. Even in case we have only one scatter set, we have to select this. So we select dip, so we click it, and then we click OK. So as you can see here, we have the name of the scatter set we previously selected. Alright, let's click OK, and let's see what happened. Let's hide map data and scatter data, and let's take a look. What do we have? So we have two water volumes which are connected using the neck. Okay, that's great. So we have blue dots and we have the line. Actually, that's the border of our analyzed water area. And since here we have cell borders drawn in the blue, it basically specifies the exact volume which we'll be working on, and the land is specified by brown cell borders. So by just taking a look on colors, so we can say that's the land or that's the water. Okay, so we have two water volumes. Alright, and the main idea right now is to create the influence on the perimeter of one, a water volume or another one. Okay, so to work with these water volumes, let's click on Cartesian Grid dataset, which we'll be working on, and as you can see, a set of buttons is being changed as well. So let's click on select cell string, and cell string in this case is exact border which was not predefined in the 3D model, but which we will be working on. And we can specify in this case only two of them, the top one, so as you can see the selected one is being colored in red, or the bottom one. In our case, let's work, let's say, with the bottom one. So we just selected the cell string, and let's create the effect on its parameters. And for the parameter, we have only one parameter. It's the haze. So let's specify how the haze is being changed in time. Let's click the right mouse button and let's select Assign BC, like in the previous video. Okay, so we will say that we will be changing the haze of these parameters water elevation. Okay, so let's select the file that contains predefined information. Okay, so once we choose it, we have a small picture that represents its information. If we would click it, we would be able to make changes in this file. Alright, so what do we have? We actually have the time in hours from the simulation start, and we have the water elevation in meters. Okay, so we have the predefined set of data, and if we would scroll down to the very bottom line of this file, we would have 5000 as the index of the most bottom row. Okay, and we have the star. So star means that we can place our own values, so our own next time step. Okay, so how to do this? So once we'll place one, another row with star will appear. Okay, so let's fill new row with information, and as you can see, once we placed it, we have a new index of that row, and we have star row on the bottom of that created automatically. Okay, so in such way we can create our own table or manage the existing one. And what do we have here on the right side? On the right side we actually have the area with the plot. Okay, in our case this plot looks really fancy because we have the high amplitude changes in this table. Okay, so let's click OK in this case, and let's apply our configuration by clicking OK. So that's great. We just set up how the water elevation in meters will be changed for this parameter, and by basing on that information, the entire water elevation will be changed as well, and water will flow in the second water volume or will flow out, and we'll be able to see not only the elevation itself of the water, but even the wave directions. Alright, in this case let's work on the model itself, and let's specify how many simulation hours we'll be using. In our case, we'll be simulating 48 simulation hours, and moreover we will be using 4 CPUs of my computer. Well, if we have one, we just specify one, but since I have 4, I will say I will be using 4 because it will be just a bit faster. Alright, so nextly, let's take a look on other information we can set up. So we have to create the man n dataset. So let's just click on create dataset, and we can place man n parameter here. In our case, just for taking a look how this module works, we'll leave the default value. Okay, so man n dataset was created, and that's great. And next we have to specify what will be the time step for this model. Okay, we can set up 600 seconds in our case. That's really nice. We can work on salinity tab, we can work on the wave tab if you like, we can work on the wind. So we can specify the wind quite differently, and once again the specification of that is just reminds us the water elevation level in meters change in time. So we basically work in the same principle. Alright, so let's just ignore the wind and wave pre-configuration and let's work on the output. So in the output we have to specify what will be the initial time in hours when we start simulation, after how many time we will save periodically information about our simulation. In our case, I use the most lowest value. I think would be fine in this case. So 2% of hour, and I said that simulation will be saved within 720 hours of simulation. Sure, we have only 48, but anyways, we have to specify this region. Okay, let's click OK button to apply our changes. We can even save our project if we like. Nextly, we can take a look on the model, check if there are any problems with the created model. Okay, we have no problems at all, and it means that we can run simulation. Let's click on CMS-FLOW tab and let's click Run CMS-FLOW. In this case, we just have to wait a bit. So let's just wait a bit until simulation process will be done. So all calculations will be done for our model. Alright, so we're still waiting for this. One quarter is being done already. Let's wait just a bit more. And we can see here a short information about our already calculated simulation part. So we just calculated around 20 hours of this simulational process. Okay, so let's wait a bit more. So after around a half minute it should be done already. Okay, the information about simulation completed info is not shown anymore, but it's not a problem since we have here the output of calculations. So calculations go in the same velocity as it was done previously. Let's just wait a bit. Okay, so from my perspective, it should be around around 90% of simulation done. So let's wait a bit more. Okay, so it shows us that simulation is being ended. Let's just close the current window. And the simulation results are being loaded automatically, as you can see. So here we have a managed set and we have the simulation folder. In simulation folder we have the current velocity as the basic information or the basic data set which will be used for showing the output, and we have two parameters, water elevation and current magnitude. Okay, and we have time steps available to take a look on simulation results. Okay, so let's work on Cartesian Grid data graphical representation. So let's click display options. In Cartesian Grid, let's click on contours and let's choose the color fill. And in Cartesian Grid tab, let's say that we are going to see contours and vectors, and we're not going to see any cells or cell strings in our output. Let's click OK to see it. And what do we have? We have the color representation of value of the water elevation, and we have vectors shown by and we have wave directions shown by vectors. Okay, so let's try to go from almost initial part of simulation which was saved, and let's just scroll down the cursor in this list. So let's just go step by step and let's see how the model is being changed in time. Okay, let's see. So we can see that their changes appeared already related to the time of the dataset which we are going through, and as you can see, the vector map is being changed. So let's see how the simulation basically moves the water between these two water volumes. Alright, so we see that color is being changed. So color change basically is related to water elevation in meters, and once again arrow shows what is the direction of waves here. Okay, so we can see some turbulence is happening here and here as well. In this case, water was just pulled through this neck, and basically it means that water came until this border, and it automatically means that the water volume was just pulled on the left side and on the right side, and basically that created this turbulence effect. Okay, let's take a look what will happen next. When this turbulence is been almost over, so the top volume of water collected more water. In this case, the elevation of the water is being increased, and it could happen that the top area water elevation is higher than the bottom one. In this case, the water comes from the top one to the bottom one, and it actually even shown by arrows that specify wave direction. Okay, so we see approximately the same picture related to vectors as we have seen previously, and we see that even colors have been changed. And as you can see, colors have been changed not equally for both water volumes, I mean for the top one and the bottom one. Okay, let's take a look on another time steps. Okay, so here the story is being repeated. So water comes from the bottom water volume to the top one. Okay, and this was the good picture. So as you can see, well, actually I have no idea if you can see this, guys, but the color is different for top water volume and for the bottom water volume. Okay, let's take a look on another time steps and what is happening there. Okay, so as you can see here, the water elevation has been really changed. So by using water elevation on the perimeters. Okay, so and once again there is a water moving happens. And the same process starts once and once again. So as you can see, overlay this amplitude change in the water elevation basically makes the same process once and once again. If we would place water elevation change in time somehow differently, then we would have I'm just guessing that we would have some another behavior of the model. Let's see what will happen nextly during the simulation. Alright, so we just reached the last saved information from our simulation process. Okay, so right now water comes from the bottom water volume to the top one, and we can see that colors are different. So we have more red for the top one color and more orange color for the bottom one, and if we would refer to the color scale, we would understand that orange water elevation is higher than the red one. So exactly that's why water comes from the bottom water volume to the top one. Okay guys, so in this way you can create such simulations with not defined in 3D model borders of your analyzed model, so you can work with variational borders of your model, but anyways you have to specify the influence, in our case at least, by assign the influence for the parameter part of analyzed volume, and then exactly this influence basically specifies the behavior of the water moves through our water volumes. For sure, here we have only one neck. Actually, we can have even a lot of different models. But anyways, this model CMS-FLOW is mostly used for analyzing how water will behave next to the bridges and next to artificial objects which actually blocks or partly blocks the water channels. So guys, thanks for watching. Definitely subscribe to the channel, write your comments, and soon there will be another videos related to simulations and other nice stuff. Thanks for watching guys.